Quiz 1 version 2, here's your solution. The first one says that we have this statement: when two objects are in thermal equilibrium with a third object, they are in thermal equilibrium with each other. What statement is that? That is the 0th law of thermo. So that's what that statement is. Now number 2, it says a closed system always contains the same matter and there is no transfer of matter across the boundary. Is that true or false? That would be true. A control volume is the one that will have mass that goes across the boundary. Now number 3, a system is at steady state if none of the properties change with time. Time is what we care about for steady state. And that will really give us some shortcuts later on in the course. And then finally the problem part. Number 4, it says we have 3 kilograms of gas in this piston cylinder assembly. It's going to undergo a process during which we have this relationship between pressure and specific volume. And it gives us our initial pressure, our initial volume, and then it gives us the final pressure. We want to find the final specific volume. Cubic meters per kilogram will be the units. We're going to do this using this relationship right here. So let's go ahead and write it out. We're going to go between state 1 and state 2. So pressure 1, V1, raised to the 0.5 is going to equal pressure 2, V2 to the power 0.5. Now we can go ahead and find specific volume, because once we find this, we can get, that's going to be our answer, right? So let's solve for that. So V2 is going to be V1 times P1 over P2. And now our exponent's going to switch to 1 over 0.5 once you do your algebra. So now if we can find all of these values, we'll be good to go. We know the pressures, those were given. Now V1, this is specific volume, remember. It gave us regular volume, so we need to convert this to specific volume. So let's go ahead and write that out. Specific volume at state 1 is going to be regular volume at state 1 over the mass. So I'll have 1.5, this is cubic meters, over 3 kilograms. That gives you 0.5 cubic meters per kilogram for your specific volume at state 1. Now all you have to do is take this, plug it back into this equation along with your pressures, and then get your number. So we'll have the 0.5 times the 250 kilopascal over 100 kilopascal, and raise it to the power of 1 over 0.5. Then you can solve. Notice pressure units go away. So when you solve, you get 3.125 cubic meters per kilogram. And that is your final specific volume.